Welcome, Lynn. I should just say quickly, because I didn't give any introductions, but Isuru and Jim head up the CCL Nuclear Energy Action Team, which is a fantastic action team. You can join it on CCL Community. There is a link up there, which we can repost. There is scads of information there. They're also both involved in other organizations like Nuclear New York and Generation Atomic, and are the most knowledgeable people I know in this field as it relates to climate. And so if you ever get a question about one of your legislators wanting to do something about climate, think of the Nuclear Energy Action Team or reach out to me or Salemi. We have incredible resources just waiting to go, raring to go. And I think you all know that our local legislator, Byron Donalds, and FL19 is the nuclear champion in the House of Representatives, which is super exciting. So we really want to get some advocacy going soon. All right, Isuru.
Great. Well, thanks for inviting me, and great to meet you all and reconnect with you, some of you. So yeah, this is a kind of the conservative climate action with nuclear energy, because I think there's a misconception, or there's a lot of conservatives might be opposed to how the current plans to solve climate change are progressing versus being opposed to climate action. And so we're hoping to bridge that gap or bring more people into the conversation and kind of solve this. So these are some of the groups that I'm associated with, as mentioned. But my background, so I was born and raised in Sri Lanka. I went to a kind of studied sciences all my life. So climate science was not up for debate. It was a fact of science. And then I started energy investment research at a hedge fund in New York. And that kind of got me to realize how energy is the kind of essential component to higher quality of life. And then I started my own fund in 2015, which allowed me to kind of focus on climate related investments or climate focused investments in energy. So I've been Citizens Climates in 2017, set up Nuclear New York since 2019. And then I'm studying for a master's in sustainability, which kind of gets me into this energy policy stuff. So kind of tying it all together with this work. So I think this is where a lot of the kind of challenges come in. So energy, and particularly electricity, has this kind of, you have to balance competing interests. And as of the climate solutions or climate policies that have been pursued by countries like Germany or California have really focused on the sustainability or the climate angle, but they have kind of not paid attention to the other kind of legs of the stool, so to speak, or not nearly enough attention, I think, on the other legs of the stool. So the other legs are the security and the reliability side of things, and then the affordability and the equitable access side of things. So what are they? And how does nuclear solve some of these issues, or maybe all of these issues? So on the security and reliability side of things, we'll look at some of these components here. I know this is a little busy slide, but this is the North American Electric Reliability Corporation, which is a nonprofit group that is set up to advise various grid operations around the North America. This is their study that came out in this month, and they identify each year. They identify what are the kind of, where are the risks to the reliability of our grids. And the highest has always been the changing resource mix, or at least for the last few years has been the changing resource mix. And there's a kind of advocacy problem. And then for the first time, and sorry, the red is kind of high risk, the yellow is moderate, and the green is not so risky. So what this in 2023, for the first time, the NERC identified the number one risk to our electric systems reliability is energy policy. So I think this is really problematic because and I think this is what is preventing more people from coming on to kind of climate action, because the energy policies are driving a big hole in our reliability challenge. So I recommend that you read through it. It's a little nerdy, but maybe a lot of the stuff that I say will be nerdy, but feel free to follow up with any of these, or we're happy to kind of address concerns as they come up. And obviously there'll be time at the end to answer questions. So that's one kind of side of things. And the other side of this is the kind of, how do you have reliable energy sources? So these are the kind of capacity utilization factors for these energy sources from the DOE. And while the kind of how much each energy use is used on a, this is a total generation capacity on a maximum, and how much of the year is it actually producing at that level. One of the factors in there is whether that generation source is an on-demand source, or if it's not. So and this took me a while to figure out as well. Electricity is the biggest machine that humans have ever made, and it's an amazing machine in that when you turn on the light switch, you want the power to come on instantaneously, right? Not 2 minutes later or 5 minutes earlier. So some kind of generation has to switch on at the point that you turn that switch. So you need these on-demand energy sources to make that happen. So we see fossil sources are on demand. Hydro is seasonally variable with like snow melt and other reasons. And then solar and wind are entirely weather dependent. We think about storage, and I'm a storage investor. That's what kind of got me into some of this work. But the amount of storage that exists on the grid today is measured in minutes, not hours or days. And the ability to scale that up to bridge kind of hourly demand fluctuations is gonna be kind of ruinous to cost. We'll get to some of that later. But so that's one angle of this. The other angle of this is the national security implications, or the energy independence concerns. So both solar and wind are kind of commoditized products that are mostly built in China. And while some of this is coming back to the US with policies like the Inflation Reduction Act, it's unlikely that it'll happen at the scale that we need, at the pace that we need to kind of onshore a lot of this stuff. So what that means is that you are, by saying all of our energy has to be solar and wind, you're saying all of our energy is now dependent upon a foreign power, who, as we know from Germany choosing to go whole hog on solar and wind, and choosing Russian gas as that balancing source to kind of, when the sun is not shining and the wind is not blowing, that has led to problems. And it is not out of the question to say, if China invades Taiwan or whatever reasons, if you're reliant on a foreign power for your energy sources, that's a problem. So that's one side. And then if you think about the prosperity side of things, the flip side of like, how do you fix this? How do you kind of get more jobs here and more good jobs here? This is a study from the DOE called Liftoff. And there's a series of them. These are really very readable studies. If you go to Liftoff DOE, you'll find them. What they show is the number of jobs per gigawatt of energy source. And you see this is old nuclear or existing nuclear is about 500 jobs per gigawatt. And advanced nuclear, the new stuff that's coming on, is about half of that. But still, it's multiples higher than what the other energy sources generate in the kind of permanent jobs. Solar and wind, if you think about it, these are kind of, once you construct it, these are workerless industrial facilities. So there is no kind of prosperity or like societal prosperity from there. Yeah, and these are the wages per generation source. This is the unionization rates, which is tied to kind of the how well people are treated, and whether those benefits are locally concentrated. So if you're a factory like setting where you can unionize and you have high pay, those benefits are local. And I've seen this when I've been to kind of nuclear towns or nuclear facility, like surrounding these nuclear facilities is an ecosystem where there's a lot of people, not just working in the factory, in the nuclear factory, but also in the surrounding towns. There's people who have good jobs and the knock-on effects of that energy source. It's also from liftoff. It's a little busy, but and we'll get to some of these other things later. But we talk about the firm or on-demand generation source. So that's mostly the fossil sources down here, and nuclear. And if you add storage to renewables, that becomes firm, whether that's clean or not, and then land use intensity. And we'll get to some of this later. And the other problem that we're having is, and CCL has been working a bunch on this, is like the amount of transmission needed to integrate low density energy sources is massive. With a nuclear plant, you could potentially go to a coal and gas facility and say, the grid is already there. All you have to do is like plug out the coal and plug in the nuke, so that you don't need to build much transmission to make that happen. And that's happening, we're seeing that happening across the coal country in the US. We talk about the economic benefits. We're not going to address additional applications. So the electricity is on 1/4 of emissions. So we need to decarbonize other sectors like industrial heat, transportation, hydrogen, yada, yada, yada. So all these other stuff, what can build those? And we will touch on the cost side. So we'll get to that. And so this is a study that was really interesting, done by the IMF. And this is called the kind of economic multipliers per dollar invested. And that because of the stuff we just talked about, the kind of the jobs and the wages and so on, nuclear has the greatest economic multiplier of these energy sources. Renewables, there are good jobs in renewables, but as of now, they're mostly in China, and there are not that many jobs. So that's this is an interesting way to kind of pitch economic development or prosperity, as opposed to kind of talk about the climate stuff. And this is another reason to kind of get people excited about a clean energy future, is if it's good for you as opposed to good for your grandkids or good for people far away. So affordability. So this I think has been at least a perception wise that nuclear is too expensive. Why should we bother? It's not gonna compete with solar and wind. So let's see how to think of this kind of in a holistic way. So we talked a little bit about the plant level costs. So we know solar and wind plant level costs have been coming down over the last 2 decades. But then in order to make electricity, which has to be, or which has always been, an on-demand service, it's not a commodity. You can't buy electrons and store it sufficient quantity to use when you need it. So it has to be an on-demand service, much like healthcare, right? It has to be when you need that healthcare, you need to be able to access it. Not like you can't have a nurse and a doctor, coming by part-time to serve your needs. It has to be when you are sick, you need to have that access. So this is the transmission lines, the storage, the kind of grid balancing, the backup. If one plant goes down, you need to have another one ready to serve that demand. So all that costs ultimately are borne by the utility ratepayers and or the taxpayer if you're talking about subsidies. And beyond, so the cost of, so this is what actually shows up in the electricity bill. And this is what shows up on the kind of balance sheet of the planet, right? So the emissions, the land use, the other issues. So when you think about the holistic cost issues, then you run into this problem of integrating intermittent generation. And this is a study done by the National Renewable Energy Labs researchers that shows that as the kind of fraction of annual generation from intermittent renewables grows, the degree of difficulty and cost of integrating that becomes exponentially higher. The short-term variability, maybe you can build enough batteries to make that happen, but then diurnal is like a daily demand, so that's harder, much harder, but maybe possible to solve. But then seasonal problems, things like you have a lot more solar in the summer, but then if your peak demand is in the winter, because now we are heating your house with electricity, etc. Those are seasonal problems, and there is no solution anywhere near kind of scalable to solve that problem. We'll see kind of how that plays out in the real world here, because that was kind of theoretical. So, and we talked about the cost declines in solar and wind, and that's great. And when people think about that is the levelized cost of electricity. So this is the cost for the kind of plant level cost. So what people have been pointing to, this Lazard is an investment bank that says, oh, solar and wind getting cheaper. And great. But then in 2023, they just came up with a study that showed, okay, this is the kind of cost of generation plant, and this is the subsidy that's currently given by the government. So that's your kind of plant level cost. And then this is the firming cost needed to make sure that the generation unit of your power gets to when and where it's needed. Actually, this is only for when, to when it's needed. This does not include transmission costs, which we talked briefly about. So when you have solar and wind, you have a materially bigger cost of firming that's needed. And that again goes on the ultimate customer's bill. And this is California. So in California, the firming costs are much higher. And that's partially because the penetration level. So if you see in PJM, PJM is Pennsylvania, Jersey, Maryland, and then about 10 other states have joined a kind of pooled grid in the region. So in PJM area, there's only 5% solar penetration and 7% wind penetration. But in California, you have 32% solar and 19% wind. And so the cost of firming is 3.5 times the cost of the solar itself. The cost of wind is 1.7 times the cost of firming for wind is 1.7 times. So it just shows how you are kind of running into this really big problem where a lot of people say, I don't want to support this climate plan because it's raising my costs. And we are kind of early in that story. I think this is going to get a lot uglier than before we make it better. So, and then let's talk about the subsidy. So this is subsidy, federal subsidies, incentives from 1950 to 2016 on a unit basis. So we hear, coal, gas, and nuclear, they are very subsidized. But in reality, on a per unit basis, they haven't been very well subsidized or very deeply subsidized because the output, I think, of each unit of a nuclear plant is so high that on a per unit of output basis, the subsidy is not that big. And this is kind of what CCL's core is trying to make sure that all these energy sources get the right level of subsidy, the honest pricing, an honest price of carbon would kind of negate the need for some government bureaucrat to decide, okay, I like nuclear today, or I like hydro today, or I like geothermal today. It doesn't make a lot of sense. So we want to kind of ensure if these guys shouldn't get subsidies because they are climate polluting, these guys should, whatever, depending on the emissions profile, get subsidies proportionate to that, as opposed to whatever is kind of the flavor of the month or the year or whatever. So that's an interesting piece of that. And then the sustainability side, which is the climate side for the most part. This is a study that the UN did last year that showed, obviously fossil is polluting, and then renewables and nuclear are least polluting, climate polluting. And one of the kind of maybe underappreciated concepts here is energy density. One uranium pellet, which is roughly the size of a gummy bear, has enough energy as 1 ton of coal. So that just means that you have much lower use of other resources and land and so on and so forth to make that energy viable. And it's very contained, which means that you can figure out, what to do with the waste and what to do, like all this other stuff. So we'll kind of get to some of that. So this is the land footprint issue, which is, I think, becoming a lot more painful again. I know there's a lot of folk in upstate New York and other places who are saying no to massive encroachments of these industrial generation energy projects, because they take a huge amount of land from forestry or farming or other human use. There's 1 square mile of land for 1 gigawatt nuclear would take 360 times more land for wind and 75 times more for solar. Other thing that we kind of get into is the kind of resource intensity or material intensity. While nuclear plants are large industrial facilities that require huge amount of steel and cement and aluminum, we see the kind of how long these plants last and how often, how much they generate per year. What that means is that even if your nuclear plant is an expensive or large project to undergo, over a unit of output per megawatt hour, it's actually the least resource intensive. Fossil sources are pretty low resource intensive on the kind of machinery side of things. And the wind and solar hydro, these require kind of, these deplete, right? So it's not like these are not forever assets. I mean, maybe hydro and nuclear are able to be refurbished again and again so that they operate for maybe 100 years or maybe 200 years. But these are kind of, solar and wind are difficult to do that because they're not like, they're engineered products that have a certain lifespan. It doesn't make sense to try to make this 100 years. And maybe eventually we'll get there, but that's not the case. So this is just the machinery side of things. But then what if you add the fuel? when you add the fuel, the coal is a huge amount of coal that goes into making each unit. Gas is high. Solar and wind don't have any fuel. Hydro, we don't include the water as a resource here, but that's fine. But nuclear uses some uranium, but the increase from 119 to 141 is very minimal compared to the material intensity of these other things. So what I mean, all this has a footprint, right? Like they have to mine this stuff out of the ground, and you have to, and that has a water impact, and that has a health impact, and so on and so forth. And then the waste disposal issue, like what are you going to do with all these toxic chemicals? I mean, these are not something that you can just, I guess people do dump it in their landfills, but maybe we shouldn't. So anyway, but is nuclear safe? I think this is a lot of people don't recognize the fact that while fossil sources, most of the fossil related deaths come from air pollution instead of the factory setting. And this is a pretty established scientifically established now. And then if you think about wind, solar, nuclear, pretty much minimal, near zero impact. And this includes the famous nuclear accidents that we all know about. But again, if you think about in the history of civilian nuclear energy, we all know the three major accidents, the name of the accidents by heart. But what we don't know is only one of them actually had a human casualty associated with it. We can go into more of that in the Q&A, but it's a pretty phenomenal fact that, in 60 years of any industry, that you can name the three accidents that have happened, and that's it. So it's a pretty phenomenal safety record despite our kind of fears. Other issue that has prevented nuclear is the perception of waste, or the perceived insolvability of the waste issue. But again, back to that energy density issue, if all the power that you used all came from nuclear, that the waste from that would fit into a soda can. So it's just that by itself is a shocking fact. So all the half a century of high-level waste from all civilian nuclear is safely contained. We know exactly where each unit is. All would fit into one Walmart. It's never hurt anybody. And by the way, the water-cooled once-through reactors that we currently use only use 3% of the embedded energy. So if we build reactors that can reprocess this waste, you could extract substantially more of that energy, as France does, as Japan does, and so on, and we could do. And there are many options for safe final disposal. This much, you think about this much, there's so much more toxic waste that we dispose that's a lot bigger than this soda can full of stuff. And radioactive is not, there's actually half-life. So radioactive falls 99% after 40 years. So support for nuclear is growing across the political spectrum, and that's good. I think that's mostly driven by the energy crisis more than the climate issue, but fine, we'll take it. So to sum up, basically, despite being a climate fanatic, this is what I kind of spend all my days thinking about. I am reluctant to support energy policies that leads to kind of economic failure, as Germany is kind of the deindustrialization of Germany is phenomenal today. It's shocking to see. And or drive energy poverty. So California, there's so many people on the streets who are, this is not the only reason, but California electricity prices is so much higher than the rest of the US after pursuing a kind of wind solar only kind of strategy. And the reliability concerns we talked about, and the national security issues we talked about, the kind of trade deficit issues. So yeah, I mean, all these things kind of drive maybe not just me, but other conservatives to say, maybe we don't want to do this the way that is being proposed to be done. So yeah, that's about it for me. Happy to answer your questions. It was a pleasure to meet with Representative Donalds, who's the champion of nuclear in the Congress. And this is me at the Nuclear Energy Action Team at the DC conference.
Great. Those are not perspectives you hear every day, and some interesting data. We don't have a lot of time here, but I think we should field as many questions as we can. Who wants to start? Maybe we don't know where to start.
I'll ask a question. What's realistic timeline for getting a nuclear plant up and running?
Much like any other thing, I mean, the first Tesla took a long time to build, but the 1000th Tesla is a lot faster, right? So we haven't, the first nuclear plant built in the US in 30 years just came online, and that took, I don't know, 12 years or something like that. But the same plant the Chinese built, or the same design, Chinese built in 5 years, the first one, and then the second one is 4 years. And even in the US one, the US, the first Vogtle 3, Jim, maybe you can answer this better. Like Vogtle 3 took longer than Vogtle 4, and the same with South Korean technology that's being deployed in the UAE. Each subsequent one is getting cheaper and faster. So we just gotta do.
Okay.
Allison?
Yeah, I had a bunch of little questions, but I think the most pressing one is I'm puzzled because you said there were not many jobs in renewables, and yet we know that there are more jobs in renewable energy in the US now than there are in fossil fuels. So how does that square?
So the chart showed kind of permanent, or not permanent, like stable jobs. So we know there is a lot of, there's a lot of jobs in the installation of these facilities, the solar and wind facilities, but they are not kind of steady jobs. And this kind of goes back to the kind of wage issue, because the wind and actually these are permanent jobs. So these are on-site jobs that remain. So what is happening is a lot of jobs do exist in solar and wind, but they're kind of migrant workers going from place to place doing installations, and they are very low skill jobs that don't pay well. So they not being at a specific location means that it's not possible to unionize there. Jim.
Just one thing to add, there also needs to be a distinction made between the large utility scale solar and wind plants and rooftop solar. And my understanding is that most of the jobs they talk about when they say there's a lot of jobs in renewable energy are rooftop solar. Okay, part of the reason and meanwhile, the cheap solar and wind you hear about are utility wind and solar. It's kind of like, you can't have everything, right? So one of the reasons why utility solar is so cheap is that it's less jobs, per kilowatt hour than rooftop solar. Now, rooftop solar, frankly, is actually quite expensive. So I just wanted to point out that little distinction too. A lot of those renewable jobs are rooftop solar specific, not so much the utility scale. So
I was surprised by the large number of jobs as well, Isuru. I think I remember hearing things like, it just takes this small team to run a plant after it's built. And I was, thinking that most of the jobs would be in building it because it's such a major construction project. So I'm surprised that there's so many ongoing jobs. Is that specific to the new advanced versions of nuclear versus the old plants?
No, I mean, but what they showed is even the new plants, they still require a lot of jobs. And I think And I think you don't actually need this many jobs, but back to kind of Drew's point about kind of efficiency, I think our regulatory framework and our kind of public perception / fear is driving to have these maybe jobs that you don't need to have. I don't know, Jim, you can speak to this better than I.
Well, I was about to say the same thing. Yeah, it's surprising. Maybe a lot of people don't know, but yeah, a large nuclear plant employs like 500 or has 700 people, maybe even 1,000 people. And there's just a lot of tasks, you know, like, and a lot of this is safety related, you know, perhaps excessive requirements, but they do all sorts of analyses, engineering analyses all the time. Like there's this huge engineering building right next to the plant where they just do studies and analyses and paper. And as well as a whole lot of maintenance and inspection tasks, you know, that the demanding regulations require. So my recollection is that way back in the past, earlier in nuclear's history, like the early 70s, there were much lower numbers of work, you know, jobs for a 1 gigawatt plant, say, but it grew substantially, you know, after TMI and formation of the NRC and such.
It's also the units that you do some of your charts on. That was like a per gigawatt, number of jobs per gigawatt, which isn't maybe the same way you normally think about solar. I mean, it's not a bad way to think about it, but you know, when people think about it, they kind of think of like the size of this, you know, massive solar farm, but it may not be producing nearly as much energy. But to the economy cares about the number of jobs, not the number of gigawatts. So it might be interesting to also look at that slide in like jobs per community or something, right? There's another one where I think slide 21, where you were talking about safety by technology. And again, it was per terawatt hour as opposed to like per decade or something. And so I think it might be interesting to look at these statistics in different ways, because it may reveal other things that could be helpful or not. I don't know, but
no, I think that's right. I think
way to look at this.
the safety issue is similar to like acceptance of risks, right? That we are accepting of driving a car, though, but we are scared of flying on a plane, though we know statistically driving a car is a lot more dangerous than flying on a plane. When a plane crashes, everybody pays attention. It's on the front page of the news. People die like driving a car every day and nobody cares, right? It's just a, so I think nuclear is the ultimate kind of fear inducing technology, because we watch all these films and they're all like radioactive monsters, and it's invisible, right? It's an invisible threat. You don't know what it's going to do to your DNA. You might, you know, have 3-eye fish or whatever, but I think nuclear now, the film, and but I think the biggest contribution that nuclear now does to the consciousness is this acknowledgement, or this like revelation that low-level radiation is not any particularly dangerous to humans, because we have low-level radiation all the time. It's in the sunlight, it's in the food we eat, it's in the earth, it's in the ground, etc., etc. But
the more we fly, the more exposed to, maybe not.
yeah, if you're flying, like, you know, I think AOC did the great post flying to Fukushima and back. She said the flight, I got more exposure to on the flight than from being in there.
Well, I really appreciate this, and I'm worried that we're running out of time. If people want to stay on, feel free. We may need to do a part 2 of this, where we talk about the advocacy issues and how we work with CCL headquarters, as you call it, with the GA office in BC, and figure out how we can support local legislators with the bills and resolutions they're proposing, like we have in FL 19, or maybe how the people in Florida can write to our senators and say, gee, we really like what's what's going on in the House here, where are you on this? Can you support some of these things? Because I don't think either Senator Scott or Rubio supported the Advance Act, which was an important bipartisan bill. So I think that we started to dig into this with Salemi last week, and maybe we can do that some more, because I think that's the ultimate goal, is how do we use this information to move things forward?
And I think this ties back to what Drew was asking, is like, how do we make nuclear cheaper and more realistic, right? And the Advance Act is exactly such a thing that is trying to, it's like Advance Act is kind of permitting reform for the nuclear industry. It's not all the things that we want, much like any other permitting reform bill, but it's a good start. And the fact that it passed through the Senate with flying colors means that maybe it's actually going to happen at the House, and the president's going to sign it.
So we should help that along as CCL.
Can you clarify that, Isuru? We were confused to this, sorry, and did it pass?
It looks like it got put in the NDAA, the National Defense Authorization Act, and that's how it got passed. Is that your understanding? Because if you go to the actual congress.gov for the Advance Act, it doesn't say that it's passed, but then the committee puts out a web release that it was passed. So I don't know what's going on. So
yeah, I thought I just saw the press release from the Senate EPW that said bill passed, but
congress.gov doesn't seem to know, but oh well. Hopefully they'll catch up soon. But I feel like now that CCL has been willing to say we support nuclear, what's our first step? What's the kind of best first advocacy move? And I would ask Jim and Isuru to advise us. And you don't have to do it this minute, but we would be happy to share this group so we can make some progress.
It raises a question that what's the companion? Is it a House Advance Act or is it a House NDAA?
Does the House have to pass NDAA or just the Senate?
The National Defense Authorization Act? I'm thinking yes.
Well, if the House doesn't have to pass it, then there would need to be another companion bill, and there'd be a different bill. So I guess that's kind of a apples and oranges problem. But Salemi has gotten some good response from the government affairs team that we're not prohibited from supporting bills as long as they're bipartisan. So maybe we ought to just grab one from the giant pile of them from Byron Donalds and figure out, can we get a few more people, a few more representatives in Florida to join with him?
Yeah, this bill, HR 26, or HConRes 26, it's a resolution.
Yeah.
It's not an act as such, but it's an expression of acknowledgement of the need for nuclear. And so maybe that's a kind of easy ask, or a easy step, because it doesn't commit the government to spend any money, or it doesn't do anything. It just says part of the clean energy arsenal, you need nuclear.
Yeah, so that's HR HConRes 26, a continuing a concurrent resolution, I think it's called, which is like a bill, has to get passed by the House, has to get passed by the Senate, but doesn't have to be signed by the president to be enacted. So it's something I learned today, trying to figure out what in the heck it was. But I'd like to use this this momentum here, and I mean, if we can't get this done in Florida,